the zoom out. Okay, hi everyone. Thank you to Ethan and Benjamin for getting me all set up here. And please do have someone interrupt me if I start veering off course or I can't be heard or the usual zoomy kind of problems here. So my name is Chris Gammell. I am the developer relations lead at Golioth. Golioth is a IoT SaaS platform that works really, really well with Zephyr because we love Zephyr. We use Zephyr. I use Zephyr just about every day in my job. I am a hardware designer, so Zephyr is kind of my first real-time operating system and ecosystem in the same way. And yeah, I'm a big fan. And so I'm going to be talking about taking your stuff to production and kind of all the things that go along with that. And then really the things around the RTOS and the ecosystem that are going to make you build better products. Today, along the way, we're going to be using our little friend here. This is Echo. This is our new mascot for Golioth. And you see there's 5 stages. I'll go into each one individually as we go through the presentation. But there are multiple stages going through production, right? That's a truism, I think. Just that you're not going to get it right on the first time, and you're going to have to make incremental changes as you move your hardware along. And so we're going to talk about the different pieces of Zephyr that can make your product better. The thing to note is that just because you're using Zephyr in a product doesn't make the underlying challenges that different, right? Using Zephyr in your product doesn't make it a different product development process in my opinion. I think a lot of the same problems exist, but I think one of the reasons I like Zephyr so much is the tools in the toolbox, and that's what we're going to be talking about here today. That's going to be on the bench, but also in the factory and also in the field, right? You have to think about the entire life cycle of your product, not just on the bench, not just in the factory, but like the thing in your final user's hands as well, and how you're going to interact with that product. Zephyr is often referred to with IoT or Internet of Things, and I think it fits really, really well in that use case, which is why I'm using it every day. A lot of the things you're going to be seeing here today are different ideas, and I'm basically, from my opinion, I'm adding these ideas to the different stages of a product, but they can really be used at any time. If you're like, no, that one, don't use I2C shell only with dev boards, you should use it in production too. It's like, yeah, fine, okay, fine. So all of these things are usable at any point in the process. Think of this as just a lot of different tools in your toolbox, but this is a huge area of study. And for the beginners out there, this is going to be kind of introducing to some of the new things. For the experienced people out there, you might be like, I already knew about this, but hopefully there's some stuff in here that you hadn't thought about. One thing to note in general around production is you just don't know what you don't know. And that's one of the things that continues to excite me and surprise me and make me cry about electronics hardware design, is that you're going to run into new problems that you've never run into before. And so then it's just about how you respond to them, how you use the tools at your disposal to solve these problems. So because this is such a big area of study, I'm going to be having a ton of QR codes. I don't know if people do or don't like QR codes. You can also download these slides at any point, or these, I think maybe download, maybe just access them. Hopefully not edit them, but that's in the lower right there. And you'll see QR codes throughout. A lot of the stuff that Golioth does, we do a lot of content around Zephyr, and so there's going to be references back to that content for more depth, right? And not just to Golioth content, but also Zephyr docs, which is fantastic, and Nordic docs, and just a lot of the resources that I use on a daily basis. Okay, let's talk about the early prototyping on dev boards section. Also, my favorite animation of Echo, soldering with the tongue out. Very, very key, very key. So the whole idea here is that you're validating your overall idea, right? You want to make sure that the thing that you're eventually building, you're probably building it for some kind of business use case. Maybe not, maybe you're using it for hobby use cases or whatever. But the end, you want to make sure that you're actually building something that people want, that you want, and yes, the hardware itself at the beginning, at this stage, doesn't matter a ton, right? You should be able to switch between different ideas because you're validating the idea. But when you do switch, this is where Zephyr plays great, right? Being able to switch between different chipsets, different sensors, different peripherals, all the things that you might need in your end design, you're going to be validating that in this first thing. And even though there is a huge learning curve, and there are a lot of training resources, we do free training. I think it's so useful to get started with learning Zephyr at the beginning so that in your prototyping stages, you're basically, once you get over that learning curve, you really start to see a lot of benefits later on, building out your own products, but also doing incremental stuff. So like the next product, you once you're in the ecosystem and the flow and you start to understand things more, you really start to level up and go faster. Okay, so first things first, let's talk about board files, right? So I'm almost always starting from a dev board. I'm starting from the top down. A lot of the times when people are asking me, FreeRTOS versus Zephyr, right? I always talk about top down versus bottom up, right? In FreeRTOS, you're almost always starting from just the scheduler and bolting stuff on and adding it up to the top, right? In Zephyr, I am always starting with dev boards where everything is known and tested and working well on a certain dev board, and then I strip stuff away or only use the stuff that I need about it. And this usually comes down to board files, creating .conf files for doing kconfig symbols, doing overlay files to change out your pins or to add in new capabilities in the device tree. These are really, really important things. One thing I will point out is the porting guide for Zephyr is probably not what you're going to do right out of the gate if you're starting a new project with a dev board, but using that methodology and understanding what you need to do under the hood is really, really useful there. And just seeing all the different boards that are already available, it's a great kind of palette. If you think about it, like all the paint colors of Zephyr and all the silicon that you get to start with, really, really useful there. This is, again, I mentioned at the beginning, like kind of starting with beginners, people who are like in the Linux world, they're like, oh yeah, menu config. Of course I know menu config. Me as a hardware engineer, I was like, what now? And so this was like a huge one for me where it's like, yes, you're building up all this stuff with the device tree. You're starting to, dig down through the structure that you're setting up in these files, but I didn't know. It took me a while to figure out that yes, you can go into menu config and see it all in one place and try and change it and modify it, and then you can click on one thing and nothing changes because there's dependencies that are baked into there too. So it's super useful to be able to see all the things that are in maybe your dev board that you're starting with, maybe your sensors that you're adding on there, understanding why you're trying to add this sensor and it's not working because of your device tree set up wrong, all that kind of stuff. So menu config is really, really key for this kind of stage when you're in the dev board phase. One thing that also is very, very useful is understanding that once you hit save and menu config, there's actually a new .config file, and you can do some diffs and start to extract kconfig symbols that you then put into your future stuff. That's really, really useful there. This is something I use all the time. So sensor and I2C shells. So I start every project as a hardware engineer using Zephyr now. I almost always start from if I have an application space where I know I need a temperature, pressure, humidity sensor, I am almost always reaching for the BME 280 because it's in tree, it's ready to go. I understand how to use it, and it's not the cheapest sensor, but it's like it just works so well. So again, in this dev board phase where I'm not cost sensitive and all these other things, it's super easy to integrate this sort of thing. And then the layer on top of that is because it's in tree, because there's a sensor driver for it, it's so easy to then go into the shell, be on a console and start to actually just extract readings, right? So like sensor get the device name at address in this case, and then you just start getting temperature out or accelerometer data out, and it's so useful from a prototyping perspective. And especially when I compare that to past times when I would go and stand up, maybe I'd go grab an Arduino and start to write code and pull in libraries and all this other stuff. It's all just there, and that's where I really find a lot of this stuff to be super useful from a prototyping and building up a product perspective. When there isn't a driver, I've chosen, I want to try out a new driver try out a new sensor that's not in tree, and I don't want to go write the whole sensor myself. I dive down a layer of abstraction, right? I go and I'm okay reading a data sheet and peeking and poking registers, and you could just do that directly with I2C. You can even do that in the shell as well if you want to, and it's you could maybe script it together a little bit, but really just the ability to activate at these different layers of the abstraction, really, really useful for me, and something that I highly recommend because it's just going to let you validate that idea in this early stage here. Okay, so I know that was kind of brief for the overall dev board thing, but there are many tools that also could apply there. So let's talk about when you start getting into your first pilot. So I usually think about this like 10 units. This is, again, we're going off my experience here, which is may or may not be useful for you, but 10 units, basically enough to program a bunch of them, get some differential behavior between them, make sure your assembly all went well, make sure when you blow up a board or two, you have a couple more, you can hand them off to coworkers. So that's why I like 10 units. And this is really when you want to start validating the actual chipsets that you want and the sensors that you want, all the peripherals that you have on there, and it's kind of just pulling it all together into one place. Big shout out to KiCad for making it easy to make PCBs. it doesn't have to look like the final form factor, but it might. And the main thing is you should be pulling stuff forward in your process as much as possible. I should have mentioned this earlier on, but one of the things when I said you don't know what you don't know, one of the things that'll be most useful in a lot of taking things to production is pulling the hard stuff forward. So things like testing and provisioning and programming, all the things that you're going to do in any kind of design, you want to be able to pull that forward as far as possible so that when you have problems with it, you can design it into your next rev of hardware. Here we go. So as you start to package this thing up and you start to pull it all together, you might want to, well, first off, you might just run out of UARTs. That's one that I've run into before where I'm just like, yeah, okay. I used all the pins or I used all the UART peripherals and it's all gone. So, alternate logging can also be useful. So RTT is a Segger-based thing that you can just kind of go and turn on. If you look at that prj.conf in the lower right there, it's super easy way to turn it on. But, when you start to get more constrained because you have these realistic hardware things like running out of pins or peripherals, whatever, you could start to output that to a different place, like your programming header, right? Other things you could do is you could start to push it to other backends. You don't just have to do it to RTT. You could do it to, I think you can also do it to RAM. You could do it cloud backends like Golioth. Golioth has a tie-in where we compress and send the logs back over the cloud. So the same thing you would see on your UART normally, you see it on the cloud. Very, very useful. And we're not the only ones who do that sort of thing. You do need to have a network connection for these sort of things. So having like a network logging capability. But if you're starting from a dev board, like I talked about, usually you already going to have that ready to go. So super useful there. Debugging tool. So this is something I'm also using, as I'm trying to wring out all of the early bugs in hardware, right? I'm using things like, again, 2 Segger things in a row does not mean I only use Segger stuff, but I have written multiple posts about this sort of thing before. So that's where a lot of this came from. And I just think it's really important to get as much, even though you're encasing this, you might be encasing this thing in plastic. So, this is a device that, oh, look at that. I have a debugger here. I'm not sure how much my video is available on screen, but, starting to put stuff into cases, you want to make sure that you have as much visibility under the hood now that you are kind of closing things off. Dev boards are great because they break out all the pins, but then you start to enclose things in plastic, shrink things down. You're not going to have as much capabilities to probe on different areas. And so you want to have other ways to do that sort of thing. So Ozone is great because it's thread aware. They're not the only one, but obviously you could start from GDB and all the baked in stuff into VS Code. But thread awareness is another one that's really, really useful, I think. And that's why I started playing around with this because, again, I was new to RTOSs. I was writing threads. I wanted to understand where I was when I halted a program. And then that was a very, very useful thing for me. Another one is system view, which is basically a way to view where you're spending all your time in your different threads as well. So that's also very, very useful. And yeah, that's the way that you would do this in some of the prj.conf, or you could have put it in your board files in your boardfile.conf as well. MCU boot is another thing. Like again, as you're pulling stuff forward in your production process, you want to make sure that you're thinking about updates, however you do it from day one, right? You want to make sure that you're really taking care of all of your updatability, right? So you can update it again when it's already enclosed in plastic. You have all this stuff set to go. Maybe you're already picking your memory parts, and so you're already thinking about how you're going to be dealing with a more constrained memory environment because you want to save money on your end device. So thinking about that now is very, very useful. MCU boot is my go-to when I'm using Zephyr, again because I'm usually starting from projects that are based on MCU boot. You can also start signing keys and having more security baked in. We'll talk about security a little bit later. But then also having, again, I talked about blowing stuff up and being able to recover from that, but being able to recover from hard memory errors and being able to get back to the bootloader and load new images in. Very, very important from my perspective. Keep losing my mouth, sorry. All right, so definitely not all inclusive there. That was the first 10 devices. Now let's get into let's talk about, now you're actually in a production, right? So maybe you're at a contract manufacturer, shortened to CM, you're gonna be maybe up to 100 units. But now you need to be thinking about things like test infrastructure, right? You're probably gonna have a programming stand, a test stand at your manufacturer. You should be pushing that forward as much as possible. You wanna be thinking about things like test points on your boards and how that might be interfering with, if you're really size constrained, you need to make sure that you have enough room for test points, you have enough capabilities in there. Maybe you have additional chipsets that give you more visibility into the final product, and in a contrary kind of motion that you're not giving so much access that it's very easy to extract your firmware later, and you're not able to someone's not able to take over your product without you wanting them to. And then finally, costing down is another one, right? As you go to production, you must always have downward cost pressures, and you need to start thinking about that as well as the form factor. So it's a lot of kind of conflicting things here, but and really DFM, or design for manufacturing, and moving stuff towards manufacturing, is kind of its own process and its own art form. But some of the tools here that are gonna help you here. So one thing that I've recently been doing, I actually just went from the 10 to 100. And I have a Rev A and a Rev B. And one thing that I didn't know about, and one of my teammates wrote about, was the managing of board revisions. So just having default board revisions in Zephyr, being able to target them with an @ symbol, having a default version in this case, which is B, but then also being able to backport and look back at the Rev A board and then have that support there. So then you see kind of on the lower right here, having all of these, so the Elixir is the board here, we have some common stuff, but then we started having hardware changes so that when I want to go and target Rev A or Rev B, of which I have both, I didn't blow up all of Rev A, and so now I want to be able to have this variation, and I want to have something very specifically called out, right? If I've changed the sensor and I try and access that sensor on the Rev A board and it doesn't exist, I want to know about that sort of thing. I want to have that in my build process as well. So that's really, really useful there. Provisioning is another really important one as you start thinking about your device going through production, being on a test stand, being on a programming stand, that sort of thing. And then they wake up and they want to get onto a network, right? So in a lot of the use cases that I'm thinking about, so the device that I'm often working with is called the Elixir. It's an NRF 9160. It is the cellular device that talks back over the cloud. And so I want to give it a certificate so when it wakes up, it talks to Golioth, the backend that my company runs, and usually, when I'm in prototyping in the Rev A, I was doing pre-shared keys, but that's not the most, those can be extracted, they can be utilized by a bad actor, that sort of thing. I don't want to give that away. I don't want to have that in the device. Instead, I could have a certificate in there, and I want them, when they first connect, they have the chain of trust, and then basically, as more and more devices come online, it's just, there's no programming step to programming credentials then. It's just basically the device wakes up, the certificate stored securely in memory, and then when it wakes up, it presents that certificate, the public key, to the cloud, and the cloud hands back and say, hey, yes, here are your credentials, you're allowed in through the front door. In terms of loading the certificates, here's one example of the way you're doing. You could do that. This is the link monitor from NRF Connect for desktop rather. But you could also have a specific firmware image that's just there for loading in the certificate. That's kind of the first thing you load on in the production line, and then later, once you have certificates on board in the secured memory, then you basically load on your production firmware as well. So thinking about some of those different capabilities and those different possibilities are really important, I think. Testing infrastructure, right? So this is one where you very easily could argue you should be doing this at the dev board stage, or before you even start the dev board stage, if you're really into that sort of thing. And I agree. And one thing that you can really lean on is a lot of the great resources from the Zephyr project itself. The fact that all of Zephyr is being tested all the time at every revision and every commit that's being pushed there. I just think that when you start to have sufficient complexity in your product, you really start to, even if you were super into the idea of testing it all manually yourself, it just starts to become onerous, and each new release, you're not always running the test the same way. So using things like PyTest, Twister, Device Sim, all these things, Device Sim is a simulator, and all these things basically can start to kind of harden your design, your Zephyr design towards future changes, right? So future changes are going to happen. You should be planning from the beginning. Another thing you could do, and my coworker Mike was on Benjamin's first tech talk, which everybody should subscribe to if you're not already subscribed. A lot of great talks there. But Mike was talking about hardware in the loop testing. So this is now kind of taking a lot of these ideas and then kind of putting them into the real world, having GitHub Actions that basically, when you do a commit, it does the build on the back end, it pushes the image out to actual hardware, programs it, and then in Mike's latest top left talk or blog post up there, he also did some testing using PyTest as well, which is really, really useful. So highly recommend all of these resources here. Grab your camera, grab your QR codes, and go dig in because, well, as a hardware engineer, I'm usually not the one doing it, but I benefit from all of the Zephyr folks that are doing this sort of thing, and my coworkers also who are doing that sort of thing. Remote firmware update, I already mentioned you should be thinking about firmware updates on the device, and that might be something as simple as having it cut out in the side of your box that you're doing. First, funny story, the first revision of this board that you may or may not be able to see, it was just a dev board that was kind of soldered into an interstitial board, and yeah, the programming header was on the bottom of the plastic, and you had to cut out the plastic if you wanted to do that. So that's not the best way to do things. So it could be as simple as putting a cutout in your plastic so you can actually access programming headers, or enabling MCU boot so you can do boot loading over USB or something like that. Or you could do something like remote, so basically taking MCU boot a little bit further using remote firmware update or over-the-air updates. And so this could be something like you might be doing it yourself, having the device go out and fetch an image. You might be using a service like Golioth that has an OTA service that's kind of out there doing a subscription to an OTA, based on its tag and its revision and things like that. But at the end of the day, you're basically pulling down this image, you're loading it into your other slot of memory. In this case, you see in the lower right here, we see that there's actually a thing, again, on the shell. You can type MCU boot and you can see the different versions you might have in memory and how their hashes, if they're okay, and that sort of thing, and then which one's actually the active one there. So just think about firmware updates as soon as possible. Yes, probably in the dev board stage, but if not in the dev board stage, when you're at 100, right? If you're at 100 units, even just plugging in 100 cables, right? That's just, you're plugging a cable in 100 times. It's super difficult to do that sort of thing. So thinking about that as soon as possible. And then, this is really going to benefit you deep into the life of your product as well. All right, so now we're at scaling production. You've done your first run, you've done 100 units, you're feeling good about that sort of thing. But now you really start to run into a lot of the different issues that are associated with production, right? And volume production at that. Maybe you're moving to a third revision of your board. Maybe you're good with the second revision. Maybe you've thrown it all away and you started over, but I would say that's probably a different problem at that point. But at this point, you're probably solidly into the costing down side of things. You might also need to start playing around with your hardware going to different versions of the world. So you might have to deal with different regulations. You might have, for example, like I mentioned, the NRF 9160, some places have LTE-M, which the modem covers, and some places have NB-IoT, and you might have to target for different regions of the world as well, based on that sort of thing. Then in that case, it's usually just a K-config switch, but then you have to figure out how you're going to switch that sort of thing. And then finally, at this stage, you really need to be like very precise on your automation and your testing infrastructure at the factory. So we're going to be talking about optimization, but then also, how do you make more of these things, right? So it's not just about optimizing cost; it's also now about other things like optimizing battery, right? And so you're really in production. Again, this is another, you could argue you're doing this way early in the process, but at this point, you really, at the scale we're talking about here, you need to be really, really good at making sure all your stuff is working here. So pin control is a system that basically allows you to have different modes for pins. One good example here, this is from one of the Zephyr doc sites, but basically you might have different drive strength on a push-pull kind of pin, where you, in a low power mode, you just turn that off so it's not leaking current. Same kind of thing for pull-ups or pull-downs in I2C context as shown here. So you might have those sort of things different, or so you can have just different modes based on which mode you're in. But more broadly, the power management subsystem is another great way to start to reduce power. And this is where a lot of the silicon vendors that are tapping into Zephyr, they basically match up a lot of their hardware abstraction layers to the Zephyr API, so that when me as a Zephyr user, I call something like the sleep mode, it then goes and does a bevy of things on the silicon itself, and that's specific to that silicon, right? So it turns off certain types of clocks or turns off different sections of the silicon without me having to think about it. Maybe I can dig down into the abstraction and do it myself, but most of the time I don't want to, and I just want to take advantage of the sleep modes. This is something where there are lots of kind of dragons in the corners, and so I would definitely do a lot of testing at this anytime you're implementing the power management subsystem, but mostly just thinking about it and thinking about how you can save your battery at this point if it is a battery powered device. And another one is the just kind of thinking about powering down entire subsystems as well. This is one that we've been doing at Golioth recently, where the board that I've been showing here has a whole secondary section. There's a secondary Wi-Fi modem. There's a bunch of sensors, and I just kind of shut it all down when I don't need it, right? And that is a great way to just make it really easy to have a load switch and turn off the power to everything. I actually have secondary switches for the I2C, so there's no like phantom powering of those as well. And it's you need to make sure that you're turning them on when you want to at boot, and then you're able to turn them on and off from your application code as well. Okay, other optimizations here. Security is probably my weakest thing, and there are a lot of great resources here. I think the lower left, is actually a talk from the first ZDS by Kevin Townsend, and the right one is actually some Nordic resources about TFM. So I am not a super super security person here, but there are a lot of samples that are built into Zephyr as well that you should be digging into at this point. And some simple things too, right? So like the default key in the bootloader, you probably shouldn't be using that at any time, even at the 1,000 stage, right? You should not be thinking about, you should have your own keys already in your bootloader for your device, so that for a couple reasons. One, just for general security and making sure that some rando off the street can't send you a firmware image. But then also, you might have even just different SKUs within your corporation. You might have different products, and if you mistakenly send the wrong firmware update to the wrong device, having a secondary key, having a key in the bootloader will also just alert you that, hey, this doesn't work on here because this is the wrong product. So another kind of just easy thing there. And then finally, using PKI or public key infrastructure, basically making sure that other people can't get at your keys and your certificates, but also the fact that you can't lose them, right? Because basically losing them is once they're gone sort of thing. And that's very detrimental to a business. In terms of data, I'm often thinking about this because I'm often doing cellular stuff, and data has a battery cost like we already talked about, but then also an actual real cost here as well, in terms of when you're paying a MVNO or an MNO. And so you might want to be cutting down on your data as well, especially as you start to scale your fleet, right? If your data costs 50 cents per device per day or something like that, and you have 1,000 devices in the field, every incremental cent basically starts to give you an extra $10. So and then that scales with the number of devices you actually have in the field. So Zephyr actually has some built-in protobuf stuff. So it's Nano PB, I believe it's called. Did I get that right? Yeah, it's somewhere in there. But there's other serialization you can implement, like CBOR. CBOR is another serialization protocol that you can use, and that just kind of knocks down your overhead instead of running JSON, and that really helps there. And then, much like you might have on the UART, you can send all of your debug messages, all the logging levels that you have within Zephyr. You might be sending those to the cloud as well, but then you also might want to turn those down. And so what the code on the right here is showing is if you wanted to go, and so this is actually a remote procedure call that my coworker Mike wrote, and basically it just steps through and changes the log level on every module within Zephyr, and we can trigger that remotely. So I can call set log level 4, and that will send it'll basically say warnings, errors, info, and debug. All of those come to the cloud, right? And I might want to do that for a particular device when it's having an issue and I want to see all of its debug messaging. But then for most of the fleet, if I have 1,000 devices out there and I want to save data, I don't want to see that. I just want to see errors. I want to see all the errors, and maybe I want to see the warnings. So I set it to set log level at 2. It sends this. It runs through all of the different modules within the Zephyr application. Again, this is after boot, right? You have to have them all compiled in so your log levels are in there, right? So it will take extra program memory, but then you want to be able to trigger those on or off, and that's what you're seeing here. So it's setting that sort of thing, and that's using a remote procedure call. And then finally, optimizing your test stands as well. So this is, as you are building out if you're building 1,000 devices or more at your CM, right? You probably want to be optimizing that process as well. And I mentioned already that basically design for manufacturing or being a test engineer, these are entire fields that are, that are past the development phase when you're into the production phase that, that this talk will not do justice to. But you can, you want to make sure first off that you're covering all of the tests that you need, basically the bare minimum to cover all of the functionality that you have on board, right? You might not need to send a Bluetooth packet to a secondary device to test that Bluetooth works, but you probably want to make sure that your device was at least assembled correctly and that you are able to output the power level that you expected, right? You can definitely test those sort of things, and then you rely on the firmware piece later to actually handle all the stack. So at the very least, you want to have an image that can go, a firmware image that's on the device in a test environment where you're just validating the output power, right? Maybe just plugging in an external, instead of an antenna, you shortcut the antenna, you are outputting some power level into a load and you're able to test that. And that might be enough for a production line, but then later you take that production line firmware image off the device, which maybe is running through a bunch of tests for LEDs and outputs and RF power that you wouldn't be using in the actual field. So you're doing this on the production line. You have your own image for the production line, and then the last stage of that is actually to load your final image onto the device, and that's actually what ships, and that's when you do provisioning as well. All right, we made it to step 5, and this is kind of the ongoing one. This is Echo pointing off to the future, and that's because this is one thing that just never really stops, right? Is if you are maintaining devices, they're out there until they take themselves offline. You take them offline, you decommission them, that sort of thing. As your capacity continues to come online, you might have 10,000 plus devices in a fleet, but this is where you really have to lean into automation, just because. Whereas, when I have the 10 devices on my desk and I'm in the Golioth console or I'm using a UART output on the screen, I can do that for 10 devices. It's maybe frustrating, but it's possible. 10,000 devices, it's just not possible. Even if you have a bunch of engineers or technicians doing that sort of thing, it really starts to become unrealistic. And so you need to just be thinking about this is where device management really becomes critical, I think, and then also automation and kind of alerting based on this sort of thing. So this is really where I start to lean into the the IoT portion of Zephyr IoT, because I think that once you can start connecting these things and they can report back to the cloud, you can start to have more software-based automation instead of just an individual device doing its own thing. So one thing, in this case, the settings subsystem on Zephyr is fantastic and really allows you to push a lot of different things down to a device, right? So I could so some of the settings that I often have are like LED colors on a tricolor LED, right? So maybe I want to boot up with a different color. That's trivial. But things like calibration constants and the amount of time between cleaning cycles on like an air quality monitor, all of these things you can push them down to the device. They're stored in non-volatile memory. That's using the Zephyr subsystem. And then I'm often also layering Golioth settings service on top of that, basically, so that it's sending these settings down to the device, and then they're getting stored locally, and it's synchronizing and telling you which are or are not actually synchronized at the time. Another thing that I already mentioned remote procedure call, but I'm often using threads and work queues. This is probably my crowning achievement as a firmware engineer, a burgeoning firmware engineer, but I put a PWM version of Mario onto a piezo element, and I'm very proud of that. And I did that all in a thread. And so that was kind of my earliest introduction to threads, implementing PWM and running through these different ideas here. But then I also trigger them remotely, right? So basically being able to send this command down to a device, send it additional control elements like which song to play, because it's not just Mario on there. It's pretty cool. And then kicking that off and monitoring it through the time, right? So basically being able to control elements of your hardware, being able to trigger that remotely using a cloud element as well, and then kind of the not having to think of it element of a thread, right? So once you've kicked off that thread, it's really the scheduler that's doing all this stuff. And so both for work queues and threads, just kind of the hands-off nature of Zephyr processing in that way is very, very useful. Oops. Another thing that's super important at scale like this is tracking volume issues. So, you get 10,000 devices. You really are only going to be dealing with the outliers. And when you start to get into these, large numbers as well, and 10,000 is just the beginning of large numbers, you need to have some exception reporting, and you need to be able to watch for bad behavior here. So that's something you can do there. I wrote a post a while back about some visualization. You might want to have, a dashboard where you can scan down there, but even that is probably not enough. You want to have some software side capabilities where it's looking for anomalies. Maybe you have some cloud side machine intelligence. Maybe you just have some some setting levels, and you start to do some statistical process control. But all of those things are possible once you ship that data off to the cloud. Another thing though is, you need the devices to kind of take care of their own. And one way you can do that is using watchdogs. This link on the left here is just the Zephyr docs are on watchdogs, but software watchdogs, hardware watchdogs, these are all capabilities to go and make sure that if the device is not operating within its limits, that it will reset itself at the very least, or call for help, or have some kind of exception reporting either on the device or on the cloud. And then finally, doing things like core dumps, and actually like being able to use services like Memfault to actually ship that stuff off to the cloud as well. Basically seeing when things do go wrong, and if you got a core dump, things are probably going pretty wrong, but understanding how that stuff actually goes and what's going on there. And especially if it's happening at scale, right? If you got 10,000 units and 1% of those units has some particular problem that you're seeing in the core dump, you can start to actually resolve that and send out firmware updates as well. In terms of extensibility, this is another thing where, again, you start to have these lots and lots of devices in the field. You want to make them even more useful. You can push things out like the file system, right? So you could set up a fat FS or a little FS, and then you could start to push stuff out to these devices and use LLVM to have local visualization. I just learned about LLEXT from Ben's wonderful newsletter, which again, I'd say subscribe to. But these are linkable extensions as well that basically you start to have some dynamic capabilities as well. Again, you might have a bunch of devices that are just a base firmware image out in the world, but you might be able to ship down a binary that can be run as an extension, and you can have different flavors of hardware at that point. The key point is, again, to just call back. You need to have some way to push your data out to your devices. You need to have some way to have some feedback, both pushing out device updates, in this case just binaries, both file, maybe JPEGs for your screen and loadable extensions for your LLEXTs, but you need to have some way to do that. And if your device cannot process them already, you want to also have OTAs. So I think I made it to the end, and I think I made it under the wire. Yes, so we have 5 stages. We went through a bunch of stages here. Many of the things I've said have been possible to apply at different stages than I was showing them, like I was mentioning, but the important thing is to be thinking about them up front. Hopefully this talk was useful for just tickling your brain and be like, oh my gosh, I really should be getting better at OTA, or I should have some kind of remote command control, or I should be using watchdogs. I meant to put in watchdogs, but I didn't put in watchdogs. So hopefully all these stages are here. I'm glad y'all were here today and that I got to present remotely. I'm sad that I'm not at ZDS/EOSS. This is my first year. I'm missing it, but I hope to be back next year. And thanks for being here. I can't hear it, but I assume there's uproarious applause at this point.
Any questions for Chris? Yeah, there's one here.
Okay.
Hello. Thanks for the presentation. I have a question. When you were mentioning about firmware updates over the air or the remote, recently I got to a problem that I changed the partitioning of the Zephyr, and that couldn't be done over the air. I just want to see, do you have any recommendation or solution for these kind of problems? So, as you said, when you have 1,000 devices out there, it's not possible to bring them back and connect it and change the partitioning. So if you have any solution, I would be happy to listen it. Thanks.
I do not. That is a tough one. I think if you had, some kind of secondary, well, I'll go just off the hardware that I have. If you had like a secondary modem, it's maybe possible if you had like external firmware programming from there, but that's again like something you don't probably have built in. That's a tricky one.
I guess I just
I'm
make
probably
a
not the
plug
right-
for Discord. Basically, like check out maybe the
Yes.
MCU boot channel on Discord. There might be solutions with like multiple like second stage bootloaders and stuff like that. That might be a way to get your answer.
That's a great one, Ben. Or ask Ben. He's another
Nope.
resource.
Not on that one. Yeah, that's a tricky one for us both, I guess. Other questions?
Yeah.
All right. And Chris, FYI, you had, I think we are like about 35 people now. So you had more people joining
All right.
as
yeah.
you were speaking. That
Well,
was
thank you
really good.
everybody for coming.
Yeah, let me check Zoom real quick in case there's a question there too. No, I think
Yeah,
we're
so all
good
the
from Zoom.
slides are in the lower right here. If you wanted to do this stuff after the fact, those are all available. I've already put in a pitch for Ben's newsletter. If you don't subscribe to that, you're missing out. Yeah, Golioth also does a lot of content around Zephyr. We also accept external authors around Zephyr too. So if you're ever interested in writing, we love Zephyr. Have I made that clear? Maybe I've made that clear. Ben, what do you think?
too. All right, thanks. Have a great rest of your
All right,
day.
thanks so much, everybody.
Cheers.
Okay.
Yeah, the QR code is actually sort of cut a bit for us in the room. Yeah, but please make sure to upload your slides on your session. I don't think you have.
I
Just
have not.
create a
I will do that
PDF,
too.
put it on sked.com for everyone to. And now if
Yes.
you can make it like really big on screen, maybe Paul will scan the code too. Yeah, there you go. Thank you.
It's in the corner. You know what? I can just edit it. What am I doing? I'm in charge here.
Yeah.
I am the captain now.
But put them on the website as well. I think that would be useful for others.
I will, definitely. Yeah, that's great.